So this is a little discussion about Google Cloud Vision. On our website we have a web page that has some links to information. The first part I'm not going to go over. It's about how to go over in this video is how to in Python or Java creates applications to run Google Cloud. Instead, I'm going to focus on Android and Google Cloud, and the Android program is going to be making a REST request to the Google Cloud Vision services. So there's a couple different ways that you can do it. There's some sample code that you can, and I'm going to bring this up in a new page, that Google has provided, and you can go to the Google Cloud Vision main web page for the current version of it. But you can take a look at that, and one of the things that you can do is you can actually clone the code. The other option is to, if you already have an existing project under construction, how to integrate it in. So this is a link to some of the various samples directly on Google. Like I said, you can go here, and of course these samples will change, but there's some of the computer vision API samples provided. You can see for different usages, and you can see sometimes they're in Java or Node.js, or in other times they might be in Android. In another example, it might be iOS code. So they try to give you a diversity. So let's return to the first idea, which is making a clone. So the things that you'll need, this is if you're going to start from scratch, this might be a way to go, or just to test out, kind of create a hello world program to, okay, so you'll need, in terms of requirement, a Google Cloud Platform account. There's a link here, you can go, it'll take you there. You need to have developed a project in the Google Cloud Council, and then of course the latest version of Android Studio. And to test on a device, this requires, this particular version of the code that I'm demonstrating requires Android 5 or higher. If you're using a later code base that you're cloning, you'll need to read the requirements there. It'll probably be a later version. So one of the things that you're going to need to do, and we're going to kind of step you through it, is we're going to create, for example, a new project in the Google Cloud. And once you've done that, here you can see going through the steps, adding a new project. You fill in whatever name or ID that you wish it to have. Once you've done that, you have your project. You should take note of your project ID that's shown here, iSight-2018, because you're going to use it later. So the next thing you need to do is you need to create credentials for accessing the API. So this is just setting up a project on Google Cloud that your Android app is in essence going to be identified as and communicate with its credentials to the Google Cloud Vision service. So the first thing you're going to need to do is create a service account with the service account key and set the key as our default credentials. So once you are actually logged into your Google Cloud Console, and you navigate, as you can see here, to your newly created application. This is called iSight. You can hit this icon. It looks like a little console prompt circled here in red, and what you'll see at the bottom here in black is actually the console that gets popped up. And so what you're going to do is you're going to type in the following items, which is actually going to create a service account. This is something you do only once every time you obviously create a new project that's going to use Google Cloud Vision. And so here's an example of me running it, and here is the disguised key that's created. Okay, alternatively, you can do it through the main console by going to the credentials, and here we are for iSight. We're hitting Create Credentials, and we're choosing one for the API key, and this is the key that'll get generated right here. Okay, so now the above is a service key. We need a secondary key specifically for the Google Vision API. And so what you're going to do is you're going to go again for iSight, you're going to go to Credentials, and you're going to hit Create Credentials API Key. And it will generate an API key, and again I've grayed it out. This is in the yellow box. That's the API key that we'll use later in the code. Yeah. Okay. So the next thing is you're going to clone the software from this site. I've locally stored it also as a zip file in case it's changed and you want to try this 2017 version. You're going to download it or clone it and open it up in Android Studio, import it as a new application. And one of the things that you're going to have to do, as we'll see below, is in the main activity.java, so there's a single activity application, Android application. It has a defined variable called Cloud Vision API key, and that's what you have to set equal to the API key that we just generated in the previous step here. Okay. And then really, when you run the sample, this is what you're going to see. Of course, I'm running it through the emulator. If you run it on a device, we'll see the image. You'll be able to capture an image, and it will then display the things that have been found. So let's look at the code to understand what's going on. This is, by the way, doing label detection. So the Cloud Vision API has a number of sub-services, if you'd like. Character recognition, label detection, and so on. Label detection is, they have a series of classes that they've predefined in a convolutional neural network that they've done training on, and basically they're telling you for that image what the content that they found inside. It doesn't tell you where those things are, but it tells you the labels of them. So hence it's called label. So it's the process of object identification, but not localization. Okay, so I've color-coded here these steps, so to speak. Importing the Google Cloud Vision packages. These are all part of the main activity.java file. Setting up the API in green. In blue, capturing the image from the camera. Now this is not using OpenCV, this is just using regular Android classes. Once you have that, encoding the image in the format needed by the Google Cloud Vision API, creating a request then in orange to the Cloud API and sending it asynchronously the image data, and then finally in gray, receiving the results and displaying the detected labels. Okay, so one of the things that we'll see in red is that there's some recommended sizes for doing processing for each of the various Cloud Vision services, including the label detection. And you don't want to send an image that's overly large. It won't necessarily help. And also, the training that has taken place with the service has specific kind of targeted images sizes in mind. Of course, scale, right? There's a whole different scale, but that's part of something that they've trained for and that they've handled with the CNN that they've developed for label detection. Okay, so let's go through. The first thing is everything up here is standard Android for a basic application, but you see here starting in purple all these import statements that I'm highlighting here have to do with the Google Cloud Vision API classes that we're going to use. In addition to that, let's go down here in green. We're setting up the Google Cloud API key, and this is my key, but it is going to be different for you. All right, so here's the onCreate method. It's just really setting up the interface that you're viewing up above, and the interface, if you notice, has an image here that's being displayed, and it has an area where the label information is displayed. So that those two areas are represented here by this image view. That is the actual image. We grab a handle to that. That's in our layout file, and it's called M main image here. And then M image details is the text view where we're going to dump all the detected labels in. Okay, some different methods here, service methods. This particular application actually lets you, rather than just take images from the camera, you can actually choose an image that's already stored on the device. Start camera is the camera is basically setting up, making sure permissions are set. Again, this is not using OpenCV, but is using just standard Android camera. Later on, we'll show an example of, in maybe a secondary video, on how to integrate it into OpenCV. In fact, that's this example here, integrating in an existing project. Okay, so moving on, in blue here, you see that we're actually capturing the image either from the gallery or the camera. And so this is basically, depending on if it's a gallery image request, then we're coming in, this is getting the data, and we're uploading the image based on the data. We'll look at this method a little bit later. If instead we're actually doing a camera image request, this is going to, again, get the local image, the camera file, and again, we'll upload the image. So upload image has is past the data basically here in this URI object, and so this is that hint that we can downscale. So basically, we're going to create a bitmap of our image, and we do that using, this is just set Android Java code. We're using a class called Media Store that lets us grab an image map, and we can scale it down to, in my case, I'm scaling it down to 1200, either in width or in height. It keeps the aspect ratio the same, this particular call. Okay. So once I've scaled down my image so I'm not transferring so much data, I'm going to send it in a special function method down below called Cloud Vision. Okay? And then the next thing I do is, so you could see what image is being worked on, I set the image view widget to contain the bitmap that we sent. All right, so let's look at this call Cloud Vision method. This is a method that's actually going to asynchronously make a call to the Vision API. And as you know, at this point, we have a bitmap. So the first thing we do is just send a little message, a loading message stored in the string file inside our resources directory that to the details text view that just says we're loading the image, loading the results basically. So here's the asynchronous task that we generate. And we don't want to wait on install the application, because we're going to make a call to Google Cloud Vision, and at this point with my home network, I'm seeing a couple second delay for getting back results from Google Cloud Vision. So it's definitely a lot slower than I thought it was going to be. So it's something to keep in mind, that you may not be able to, you're not going to be, at least I'm not going to be processing anywhere near video frame rates. In fact, quite slow. So here we have, in the async task, it has a method that we're overriding called do in the background. And so this is what we're going to set up. So the first thing is we're going to create an instance of an HTTP transport class, because we're going to make a REST request via HTTP, and we're going to be using JSON to package and receive our results. So this is a class that we get from the Google Cloud Vision API. That, if you notice, is one of the classes that is imported. Right, here we go. The request initializer, Vision. These are some of the classes from the Google API services, Vision specifically API. So let's go back down. All right, and so we're setting up our initial request, and here you can see we're making a new instance of it, passing our key, so it knows that we're authorized. We have a project associated with Google Cloud Vision. This particular class has a method called initialize vision request that we're overriding, which is just giving some information about our certification header and things like that. And if you notice, those are also defined at the top underneath the Google Cloud Vision API. There's here the Android certified header and package header. You're just going to copy and use this information. Okay. Moving on down. Obviously, you're going to copy the whole thing, right? Because you're cloning the code. So moving on down, it just sets up these headers. All right. So we have this request initializer, and what we need to do right now is we need to create the instance of Vision Builder, which is associated with the HTTP transport object that we created up above and is associated with the JSON factory instance. And in this builder, we're going to set the Vision initialize request initializer that we created right here. Okay, in the step before. Okay, this creates a Vision object that we are going to utilize, as you'll see a little bit later, to actually make our request. All right. So we have to add the image to the request, and in order to do that, we create an instance of a batch annotate image request. You could actually add more than one image. I'm going to just show you this code only is adding a single image. But here we go. We're going to create an instance of image. It's going to be associated with the bitmap that we passed in a moment. So what you see doing here is that we are actually taking and creating from the bitmap that got passed. So again, remember, the bitmap is an input, right? That's the image that we had previously downsampled that gets passed as a parameter to this method called Cloud Vision. Okay. And so, I'll just zoom in a little bit here. Okay, and so what you'll notice is that we're basically compressing with a JPEG standard the data and saving it into the byte array output stream, which we then store in a array of bytes called image bytes. And moving on, we're taking and we're adding that, we're encoding it in base 64, and then adding to our request that image. Finally, that's the image added. Any other features we need? For example, we need to say what we want to do with this image. So we want to do label detection. So again, with the annotate image request, we have to add some different features. For example, this is how we add the fact that we want to do label detection. And for label detection, we want to have a maximum of 10 results. Okay. All right. So we're going to go ahead and come down here to our annotate request. We're going to take vision images. We're going to add that batched annotate image request that we just set up. And at this point, we're pretty much ready to go. So this is where we actually execute the request. We say this annotate request object dot execute, and this is where it's going to go ahead off and make the request. And this is inside of async, so this will actually take time, but the main application, the actual Android application, doesn't have to pause for that. It can still be responsive. When it's done, it's going to return the data in response, which you notice we're calling a method convert response to string, which I'll show you in a minute, but that's what actually gets returned from this object. If for some reason there is some kind of a failure, we just print out this information. So let's take a look at the convert. Here we go, response to string. And so you can see I'm building out a string messages called I found these things. And again, here's the response object. We can get the responses, which from that we get labeled annotations, which will become a list of entity annotations that we're basically going to cycle through each label in that list and simply add information about the score and the description. So going back up all the way to see the output, this is the score, which is like the certainty value. The higher you are, closer to 1, the more likely it's that case. So this is recognizing this is some kind of game. Then the next label, the next likely label is pattern, followed by chessboard and board game, and then square. That's probably the green square that's detecting that. And then you can see some other unusual things: design, symmetry, line, font, and computer wallpaper as other labels that are found there. Okay, so again, that is the Cloud Vision bitmap that gets called asynchronously, and that is it. That's how it works.